Thomas Edison, born in 1847, was interested in science and engineering from a young age. In his early 20s, Edison moved his headquarters to a lab in Menlo Park. This lab was the place where Edison made many of his inventions, granting him the nickname, the Wizard of Menlo Park. Edison patented thousands of inventions throughout his life. However, one, although not his most popular modification, was the most influential of them all, the improvement of the DC system. DC, which stands for direct current, works naturally by flowing electrons in one direction. Edison invented the first large-scale system that used DC, giving him a monopoly on electricity. But the DC system had a downside. Because the electricity only flowed in one direction, it lost efficiency quickly and could only travel about 1 to 2 miles. Despite this limitation, it worked at the Pearl Street Station, the first central power plant to use DC. Edison's improvements on the current allowed for the illumination of multiple blocks, providing the first indication to the public that electricity could be used practically in their daily lives. However, Edison's problems would soon be addressed by a more theoretical physicist, Nikola Tesla. Tesla emigrated from Serbia to the US in 1884 in hopes to bring his ideas to America, where he would have better opportunities. Edison hired this bright new mind to work on DC motors, and gave him the task of improving the efficiency of these machines. The incentive for Tesla was $50,000, which Edison allegedly promised him for a redesign of the motors. While working for Edison, Tesla had a vision of alternating current. This type of current could transmit electricity very long distances because it flowed not just in one direction, but back and forth along a single plane. Tesla proposed the AC system, but the idea was quickly shot down by Edison. After 6 months of working for Edison on the DC system, Tesla was able to improve this unpromising technology. When Tesla demanded the reward for his work, Edison dismissed his promise of the money as a joke. This made Tesla quit working for Edison and motivated him to work on the future of his AC system. Determined to prove to his opponent that his AC system was superior to Edison's DC, Tesla patented the AC induction motor in 1888, officially starting the War of the Currents. Tesla's AC system could theoretically power entire cities from a single generation point, which DC could not do. The back and forth movement of AC allows it to travel efficiently, because transformers can speed up the electricity for long distances and slow it down for safer use in homes and businesses. However, Tesla still had a problem. After being let down by Edison, he needed funding. He partnered with businessman George Westinghouse, who saw AC's potential and offered to fund it. This partnership gave AC a way to show its true potency. Edison, seeing this potentially powerful partnership, sought to undermine and discredit AC. He launched a massive campaign, publicly claiming that AC was extremely dangerous and could kill people if not handled properly. Edison's team publicly electrocuted a wide variety of animals, including dogs, cats, and other animals, to show how lethal AC electricity was. His campaign worked. In the public view, AC was seen as deadly, and DC was seen as the safer alternative. Amidst the public rivalry, there were also numerous legal and business conflicts. Edison's company, heavily funded by J.P. Morgan, began filing patent lawsuits against Westinghouse. Westinghouse was dealing with massive financial pressure because his company had paid Tesla a large sum for his patents and was now spending even more to install infrastructure and promote AC's image. In 1892, Edison General Electric Company merged with Thomson Houston Electric Company, forming the conglomerate General Electric. The contrast between Edison's enormous financial backing and Westinghouse, who was on the verge of bankruptcy, further helped push Edison to an upper hand in this battle. The 1893 Chicago World's Fair was being built to celebrate the 400th anniversary of Columbus's voyage to America. The organizers really wanted to dazzle the public with innovation, architecture, and technology. Edison had hoped to supply the electricity for the fair, but the limitations of DC meant it couldn't power such a massive event. The fairgrounds required over 75,000 incandescent lamps to light buildings, streets, and fountains, along with hundreds of motors to run exhibits and rides. Edison submitted a bid based on his DC system, around $1.8 million, which was later reduced to $554,000. But it was estimated he would need dozens of power stations. Westinghouse, using Tesla's AC system, proposed a single high-voltage system with multiple transformers that could handle everything with far fewer power stations. Westinghouse's AC bid came in around $339,000. This significant difference, along with the technological advantages of AC electricity, eventually resulted in a deal for Westinghouse. Tesla and Westinghouse worked together to develop a system to light the White City by strapping the transformers from the generator to the fairgrounds and outfitting the buildings, fountains, and walks with thousands of incandescent lamps. On opening night, May 1st, 1893, the fair was lit up brilliantly with light. Thousands of lamps lit up the streets, fountains sparkled, and buildings glowed as visitors strolled through, scarcely able to believe their eyes. No one had seen anything like it. It was not just light, it was proof that AC electricity was safe, practical, and majestic. With the resounding success of the Chicago World's Fair, people's perspective of AC electricity was starting to shift. The Chicago Tribune, which had previously been skeptical of AC, published the article Electricity at the Fair shortly after the fair, marveling at the scale and reliability of Westinghouse's AC system. The following major hurdle for the AC system was to demonstrate that it could power entire cities from a distance. Niagara Falls, one of the most powerful waterfalls in the world, was selected for a major hydroelectric project. Westinghouse, using Tesla's AC system, designed a plan to capture the energy of the rushing water and transmit it to the city of Buffalo, about 26 miles away. Edison's DC system was fundamentally incapable of transmitting energy that far without massive losses. Engineers built the Adams Power Station, a massive facility at Niagara Falls, complete with generators, transformers, and transmission lines. Workers faced harsh conditions and technical challenges while designing this power plant. They finished the project in a year and a half, and although some doubted Tesla's system, the night of November 16, 1896, had the potential to change their minds completely. The night of November 16, 1896, was tense and electric. There was a level of excitement in Buffalo, and even beyond, about Tesla and Westinghouse's progress. The DC system of Edison's remained as a constant reminder that the War of the Currents was not yet over. By the time evening fell, crowds had gathered near the city streets and the power lines leading in from Niagara Falls. As total darkness descended on Buffalo, all attention centered on the Adams power station. Machinery buzzed, turbines turned, and engineers made final checks on their devices one last time. Then, possibly the most important moment in the history of the power industry, the operators threw the switches on. One by one, the transformers were energized, and the current surged through the lines to the city. Homes, factories, and streets were suddenly filled with lights. Windows shone with the brightness of incandescent bulbs, lamps lit up, and entire city blocks appeared to glow with life. The people gasped as it appeared the city came alive as night fell, due to the invisible power of AC electricity. For the first time, Tesla's vision of long-distance electricity had arrived along with a city that made the case that AC electricity could work where DC electricity had failed. The Adams power station produced around 50,000 horsepower, roughly the amount of energy emitted by 8 to 10 locomotives running at the same time, transmitted across 26 miles from Niagara Falls to Buffalo. Over 10,000 incandescent lamps flickered around the city for 6 to 8 hours. However, Westinghouse's company was on the brink of financial collapse. The costs of building all the infrastructure, paying Tesla for his patents, and promoting AC had pushed the company dangerously close to bankruptcy. In desperation, Westinghouse met personally with Tesla in 1897. Due to their original agreement, Westinghouse owed Tesla enormous royalties. However, Tesla, out of loyalty and a shared vision for the future, tore up the contract himself, essentially forfeiting what would have been over $300 million in today's value. Removing this financial burden allowed the AC system to survive just long enough. With finances stabilized and public support behind it, the AC system finally prevailed. Although General Electric and Edison's DC network had enormous financial resources, all that money couldn't fix the fact that DC simply couldn't transmit electricity efficiently over long distances. Over the next few years, DC systems gradually fell out from mass-scale electricity production and were replaced by AC infrastructure, following Edison's campaign by a decade. One of the most infamous events with regards to the safety of the AC system occurred: the electrocution of Topsy the elephant in 1903. Topsy, an elephant in a circus, had killed a man and had become aggressive. She was then sentenced to death by her owners. Some people who had previously worked at Edison's company proposed the use of the AC system to carry out the elephant's execution. She was electrocuted to death using AC system in front of a live audience at Luna Park, Coney Island. This event was recorded, and news of it spread everywhere. One myth arose that Edison was directly involved in Topsy's execution. While he was not directly involved, the controversies surrounding AC and Edison's campaign encompassed the time period of the electrocution. So although he didn't kill the elephant himself, it was often misattributed to him. Even after the controversial electrocution of Topsy the elephant, the public had largely accepted AC electricity. Cities across the US began installing AC systems for street lighting and factories. AC became the go-to choice for powering growing urban areas, and DC systems were gradually absorbed or replaced. Ultimately, Edison and Tesla's inventions laid the groundwork for the entire modern electrical world. Tesla's AC systems created power grids that are still used to this day to provide energy to cities. Edison maintained his influence through improvements he made to DC, as well as the hundreds of patents he obtained that influenced electric lighting, communications, and industrial machinery. Edison passed away in 1931, and Tesla in 1943, but their legacies will forever live on. The War of Currents was not simply about who won. Rather, it was about establishing the foundation for the electrified world we live in today.